All right, this is the similar right triangles lesson. And what you did in class was you went ahead and chose one of the two triangles, measured the side lengths that are listed down here, and measured the angles. And what we recognized was inside of each of these right triangles, there really are three right triangles. We have the large triangle, triangle ABC. Oops. We've got the medium-sized triangle right here, triangle BDC. And then we have the small triangle, triangle ABD. So we measured all of these side lengths and angles, and we moved on to the next page and we listed the corresponding sides in the large, medium, and small triangle. And then we said, are these triangles similar? How do you tell if they're similar? Remember, you can check angle, angle similarity, side, side, sides. All the corresponding sides are proportional. Or you can do side, angle, side. So to check similarity, we looked at the ratio between each of the corresponding sides and checked if they're proportional. So we said, is AB, which corresponds to BD, are those equal to the corresponding segments BC and DC and the ratio between AC and BD? And we found out those were all equivalent. Therefore, these two triangles are similar. And then we did that, compared the large to the small, and we also found that those ratios are equal. Therefore, we can say the triangles are similar. If so, how? By side, side, side similarity, because all three sides are corresponding and proportional. Then, or you could say by angle, angle similarity, because we see, oh look, we have one angle, those two angles are corresponding and congruent. And then if you look back at the picture, look at this part right here. You can see that these two angles are, they overlap, right? So that must be the same angle. So if we look back at go back to our part where we separated the three, these are the same angle. Those are congruent. So right there we can say these two triangles are similar by angle, angle similarity. Then if we want to compare large to small, well, we see we have two right angles. And then right here, these angles overlap, angle A, and that is right down here. So by angle, angle similarity, again, large is similar to small. And if large is similar to medium and large is similar to small, then all three are similar triangles. So then we went ahead and just practiced, name the three similar triangles using this figure. So just as I did above, I would really divide this into three similar triangles. So we're going to just call this my large triangle, my medium triangle, and my small. And it's okay that they're not proportional. This is just to help us divide up our similar triangles. So this is my right angle. So my large triangle, we're going to go A, B, C. Then on my medium triangle, looks like I have my right angle at D. And then my short leg, so B is here and my long leg is here. And then finally for my small triangle, D again is my right angle, A is the segment ending my short leg, and B is ending my long leg. So when I name similar triangles, I have to go in the corresponding direction with corresponding lengths. So it goes A to B to C. So this one will be B to D to C. And this one will be ADB. Now we're going to connect that to actually try to find missing side lengths. So again, I have this divided into large, medium, and small triangles. And so I'm going to just go ahead and write in my corresponding lengths on these triangles. So I see here's my large right triangle. I'm going to outline this. And I'm on that triangle, I have my hypotenuse. That has a length of 14 because 10 plus 4. And then I have Y for my short leg. Then I have on my medium triangle, if I outline that in orange, here's my right angle. So it looks like I have my short leg and my long leg. So I can call that X and 10. And then I have my small triangle right here. Let's see, we'll outline that in pink. And it looks like I have my hypotenuse, y, and my short leg, 4. So 4 and y. And x. Now I can go ahead and set up a ratio and a proportion, and I can solve. So first I want to find, let's find x. My hint is to look for sides that are corresponding, that both have a number or a variable listed. So it looks like I have 10 and x in this corresponding position, and then x and a 4. So I could say 10, since they're similar, the ratio between 10 and x is going to be the same as x and 4. Then I can go ahead and solve. I'm going to go ahead and cross multiply. So if I cross multiply, I'm going to get 40 equals x squared. And then I can take the square root to solve for x. So I'm going to say x equals the square root of 40. I can leave it like that and simplify my radical. The approximate value is 6.32. That's the rounded value. So x is, I'm going to just leave it as the square root of 40. Now I could do one of two ways. I now know what x is. Same here. So I could go ahead and set up another ratio. I could compare y to 4 and 14 to y. Or I can say, well, since I have 2 of my 3 sides in a right triangle, I could do Pythagorean theorem. So let's do it both ways, where we call the 2 legs A and B and the hypotenuse C. So we would say square root of 40 squared plus 4 squared equals y squared. Go ahead and solve square root of 40 squared. That's square root of 40 times itself, so 40 plus y squared. Oh, sorry, that's a 4. So 4 squared is 16 equals y squared. So this is 56 equals y squared. Take the square root, take the square root on both sides. So I could simplify this radical, or I can say the square root of 56 is approximately 7.48. So I'm just going to leave this as y equals the square root of 56. Now if I want to do it the other way, I'm going to do this in, let's do it in green. I could also set up a ratio and a proportion. So I could say y corresponds to 4 as 14 corresponds to y. And you want to make sure you do this with appropriate triangles. So on this side I have y and 14 on the top, so my big triangle, and my small triangle on the bottom. So if I cross multiply, I'd get y squared equals 4 times 14, which is 56. And then square root, and yep, I get the same answer. So you could use either way. So let's just do one more example. Here's my large triangle. We'll do this a little faster this time. So I have my hypotenuse, which is 19, my long leg y. Then I have my medium triangle here. Looks like I have all 3 sides this time, so I have 15. Oops, yikes. I have 15. I have x and I have y. And then on my small triangle, I have 4 and I have x. So then I can go ahead and try to set up my ratios. I'm going to for sure use this triangle because I have all 3 sides. I'll start with y this time. So I'm going to say y corresponds to 15 as 19 corresponds to y. So y over 15 equals 19 over y. I can go ahead and cross multiply. So 15 times 19 is 285 equals y squared. Square root that. And I get approximately 16.88, but I'm just going to leave this as the square root of 285 just so I don't have to worry about rounding. And I'm not going to simplify yet because I can use this to solve for my other leg. So I could plug that in here, square root of 285. And if I want, I can use Pythagorean theorem, or I could set up a ratio. So I'm going to set up a ratio. looking at 15 and x and 4. So I could say, I could also do 15 and square root of 285 as 19 relates to square root of 285. So 15 over x equals x over 4. 15 times 4 is 60 equals x squared. Take the square root of both sides. So x equals the square root of 60. So then I've solved all my missing sides. So that concludes the lesson for similar right triangles, and then you can complete the handout, which is on the next page in the packet with number 1 through 6.